Today we are discussing one-step equations. An example of a one-step equation is something like that. 1 plus 2 equals 3. There's only one step, one operation. That would be plus. But today we're going to be doing a little bit of algebra. And algebra is when we replace one of the numbers with a variable. I know that this problem looks real obvious. You obviously know that A is 2, but we're going to be practicing some steps. With these one-step equations, these are like the baby problems, and we're going to be practicing the steps so we'll be ready for the equations that have way more than one step. We're going to start with one-step equations that have either addition or subtraction. So let's look at these little balances. They're like the balances you would use in science. And balances are like equations. Both sides have to be equal for it to be balanced. So 11 minus what would make 6? Well, 11 minus 6 is 5, so would 11 minus 5 be 6? Yes. What would need to be in the box in order to keep this equation equal? 4 plus 6 equals 10. And what would need to be in this box in order to keep it equal? 3 plus what makes 15? Try taking 3 away from 15. What would you get? 12. Okay, let's look at some models. I have 1x, and I have 4 positives. That's a positive. And then on the other side of the equation, I have 10 positives. So my equation is x plus 4 equals 10. What would the x need to be in order to make this a true equation? Well, I could take away 4 from both sides, because if you do something to one side, you have to do it to the other in order to keep it balanced. So if I take 4 from both sides, this now says that x equals 6. And could I plug in a 6 where the x is? And that be true? Yes. So x equals 6. Let's try another model. I have 1x, and then I have 2 positives, an equal sign, and then there are 6 positives on the other side. So my equation is x plus 2 equals 6. I didn't leave the 1 in front of the x because it's just understood if there's no number, there's just 1. So what plus 2 would give me 6? You're probably already thinking 4, but let's look. Could I take 2 away from both sides? And then the equation would be x equals 4. So the solution is x equals 4. This time they put the x on the other side of the equation, but we still do it the same way. There's 4 positives, an equal sign, 1 positive, and 1 positive x. So the equation is 4 equals 1 plus x. So 1 plus what makes 4? Probably know that in your head. But what if we take this 1 away from both sides, then it says 3 is equal to x. And when you're writing this solution, the variable needs to stay on the side where it started. So if it starts on the right side, it still needs to be on the right side when you're finished. Now let's do some examples that don't have models. The first thing I'm going to do is find the equal sign, and I'm going to draw a wall, because I want to make sure that whatever I do on this side, I also do on this side. So I need to draw me a wall so that I can see both sides of the equation. Then I want to find the variable. There's my variable. It's an x. And I want x to be all by himself. That's the only way I can really get to know who he is if he's all by himself. So the one I want to get rid of is the -5. The opposite, think about opposite. What's the opposite of a -5? +5. And remember, whatever you do to one side of the equation, you have to do to the other in order to keep it balanced. So I'm going to +5 on both sides. 17 plus 5 is 23. And then -5 and +5 would make 0. So they're canceled, they're gone. And the only thing left is the x. And you need to be sure to bring the equal sign straight down. The equal sign stays on the wall. Let's try another example. Okay, the first thing I did was draw a wall. And then I want to find the x, or the variable. Sometimes it's a different letter. So this is the number I need to get rid of. What is the opposite of +18 or +18? The opposite would be -18 or -18. Since +18 and -18 are opposites, they cancel. And the only thing left on the left side is the x now. The equal sign comes straight down on the wall, and this is a -10 minus 18, or a -10 and a -18. Since they have the same sign, remember the song, same signs add and keep. So we're adding those together. And since it was all negative, it stays negative. So x equals -28. Another example. Remember, start the wall, then find the variable, and we need to get rid of -6 or -6. The opposite of -6 is +6 or +6. Same thing. So since these are opposites, they cancel, and the only thing left on the left side is x. Then the equal sign comes straight down, and 12 plus 6 makes 18. So x is equal to 18. One more example, and then we'll work together. Draw the wall, find the variable. So we need to get rid of him. What's the opposite of +5? -5. Make sure to write it on both sides. +5 and -5 are opposites. They would make 0, so they're canceled. And the only thing left now is the variable. Equal sign comes straight down on the wall. And 11 minus 5 is 6. So x equals 6. Now we're going to do some examples together. We're going to do one-step equations, add addition or subtraction, And if you're looking at your paper, make sure you're on the guided practice side. And we're going to do these together so that you can practice. Number 1, first thing I did was draw the wall. And then find the variable. So we need to get rid of minus 2. The opposite of minus 2 is plus 2. And I know right now you're thinking, oh, I could just do this in my head. Be sure to show the steps because these are the baby steps. We're going to have way bigger problems before this is over with, and you need to practice doing the steps correctly. So we have plus 2 on both sides. The 2's cancel. N comes down. He's on the left, so he stays on the left. Equal sign stays on the wall. And 21 plus 2 makes 23. Number 2. Draw the wall. Find the variable. So we need to get rid of minus 6. The opposite of minus 6 is plus 6. Make sure you do it to both sides of the equation. 19 plus 6 makes 25. And the equal sign comes straight down. The 6 canceled, so the only thing left on the right side is the variable. N is 25. Notice how N is on the right side. It started on the right side, it ended on the right side. I didn't switch it over to the other side. Number 3. Ooh, I can already see we have a negative number. Draw the wall, find the variable. So the one we need to get rid of is plus 8. The opposite of plus 8 is minus 8. So we have a negative 32 and a negative 8. Same signs, we just add. So 32 plus 8 makes 40, and we keep the sign. Equal sign goes straight down. The 8's are opposites, so they cancel. And the only thing on the right side is N. Number 4. Draw the wall. Find the variable. So we need to get rid of negative 5. The opposite of negative 5 is positive 5. Make sure you put positive 5 on both sides. 17 plus 5 makes 23. Equal sign stays on the wall. Since the 5's are opposites, they cancel, and N is the only thing left on the right. Number 5. Oh, we've got decimals now. Draw the wall. Find the variable. So this is who we have to get rid of because he's next to the variable. The opposite of negative 3.7 is positive 3.7. So I need to do positive 3.7 to both sides. Remember, when you're adding and subtracting decimals, you need to be sure to line up the decimals. Okay, the 3.7s are opposites, so they cancel. N comes straight down. Equal sign straight down on the wall. And 8 plus 7 be 15, carry the 1, 10.5. So n is 10.5. Number 6, draw the wall, find the variable. So we want to get rid of what's next to the variable. That is 8.75. The opposite of 8.75 would be negative 8.75. And again, remember to line up the decimals. So 5 minus 5 would make 0. Can't take 7 from 2, so I have to borrow. 12 minus 7 is 5. And then 14 minus 8 is 6. So that is 6.5. Equal sign straight down. These canceled, so the only thing left on the right is n. Number 7. This one has a fraction, but we still do it the same way. Start with drawing the wall, find the variable, and we want to get rid of whatever's next to the variable. So it's a positive 1/5. The opposite would be negative 1/5 or minus 1/5. And since these are opposites, they cancel, and the only thing left on the left is n, equal sign straight down. And then since these fractions both have the same denominator, all I need to do is subtract the top number, the numerator. So 4 minus 1 makes 3, and the denominator is a 5, so 3/5. N is 3/5. And the only reason that I could just add or subtract the top is when the denominator is the same. That won't happen very often. Number 8, for example. Draw the wall, find the variable, and we need to get rid of 1/4. But I notice they do not have the same denominator. So I need to find a common denominator. To find a common denominator, or a least common denominator, you find the multiples, or skip count. So if I was skip counting by 3s, I would go 3, 6, 9, 12, 15. And then if I was skip counting by 4s, 4, 8. Look, they have one in common. So the denominator is going to become 12. So I'll go back over here, and I want 4 to become 12. Well, I can't just change it. 4 times what makes 12? 4 times 3. So if I multiply by 3 on the bottom, I got to multiply the top by 3. So 1 times 3 would make it 3. And then I need to change this one to also have a denominator of 12. What would I do to 3 to make it a 12? 3 times 4 is 12. So if I multiply the denominator times 4, I need to multiply the numerator times 4. 2 times 4 makes 8. Now I want to work the problem just like I've done all the others, but I want to use my new fractions because they have the same denominator. So I need to get rid of 3/12. The opposite of positive 3/12 is minus 3/12. Minus 3/12 from both sides. And since these are opposites, they cancel, and the n comes straight down, and the equal sign comes straight down. And now they both have the same denominator. It's a 12. So I just need to subtract the numerator. 8 minus 3, which is 5. So n is 5/12. Number 9. Draw the wall. Find the variable. And then we want to do the opposite of whatever's next to it. But I notice that these are fractions and they don't have the same denominator. So remember, we need to skip count or find the common multiple. So if I was skip counting by 2s, 2, 4, 6, 8, 10. Well, the other one is a 10, so I could multiply 2 times something and get 10. 10 can be our common denominator. 2 times 5 makes 10, so I want to multiply the top number by 5. 1 times 5 is 5. Now I can go ahead and get rid of what's next to the variable. It says minus 1/10, so the opposite would be plus 1/10. And you need to make sure you do it to both sides. Since these are opposites, they cancel, and the only thing left on the left is the n. Bring the equal sign straight down. And since they both have the same denominator, I just need to add the top number. So 5 plus 1 makes 6. But this needs to be simplified. Your answer always needs to be in simplest form. 6 and 10 are both even numbers, so they can be divided by 2. 6 divided by 2 is 3, and 10 divided by 2 is 5. So n equals 3/5. Number 10. Start with the wall. Find the variable. Get rid of what's next to it. So the opposite of minus 20.50 would be plus 20 and 50 hundredths. So we need to add that to the other side, but remember, we're supposed to line up our decimals. Since this doesn't have a decimal, that would go at the end. So 40 plus $20.50 would make $60.50. Equal sign straight down on the wall. And since these are opposites, they cancel, and on the right is only n. Now you're going to do the other side of the page by yourself, no help. No help from me, no help from your neighbor. Finish the page, and then you'll put your answers into Canvas. Remember, on question 7, you're going to need a common denominator. So if you skip count by 2s and 6s, the first thing they both have is a 6. So the common denominator is going to need to be 6. So what did I do to 2 to make it a 6? I need to do the same thing on top.